Welcome, everyone. My name is Dion Rossiter, and I am the Executive Director of Science at Cal. It is so exciting to have you here for our September Midday Science Cafe collaboration between UC Berkeley and Lawrence Berkeley National Lab, titled Smoky Skies Ahead: How to Reduce Indoor Smoke Exposure to Improve Public Health during wildfire season. We have two amazing, brilliant, and very well-versed in communication scientists here with you today, Dr. Stephanie Holm and also Jacob Bueno de Mesquita. I'm going to start as usual with a land acknowledgement. So thank you for allowing me the time to recognize that Berkeley sits on the Hu-Chun territory, the ancestral and unceded land of the Ohlone people, the successors of the historic and sovereign Verona Band of Alameda County. This land was and continues to be of great importance to the Ohlone tribe and other familial descendants to the Verona Band. Every member of the Berkeley community has and continues to benefit from the use and occupation of this land since the institution's founding in 1868. By offering this land acknowledgement, the Berkeley community not only recognizes the history of the land on which we stand, but also recognizes that the Ohlone people are alive and flourishing members of the Berkeley and broader Bay Area communities today. So again, thank you so much for allowing me the opportunity to provide that land acknowledgement. We want to say we have our fall programming settled. We are going to be talking more about land management due to climate stressors, again, with Carrie Johnson and Erica Cirillo Woodburn on October 21st. So mark your calendar. And then we'll also be chatting about the microbiome on November 18th. And as usual, we will take December off because of the holidays, but we can't wait to see you soon. As a reminder, this presentation, this video is being recorded. We will send out a recording to all of you who joined, additionally, those who RSVP'd, and it will be featured on all of both of the lab and UC Berkeley Science at Cal's YouTube channels. And again, thank you for being here. So if you want to share it with your friends after the fact, please do. The other thing I want to mention is that there is a closed captioning available for this program. If you don't see live transcript available at the top of the screen, look at the bottom of the screen and you should see either a closed captioning or live transcript button, or you might need to click the three dots that say more to find that button. I feel like Zoom is always changing things, so it might show up in a few different places for you. The last thing I want to mention is that, as usual, all of our programs are very interactive. We love to get your feedback, so please, we want questions either in the Q&A box, you'll see that Q&A chat, or in the chat box where you see the chat button. So we don't mind if you add questions to either spaces, and we'll make sure that both of our speakers are provided your questions from the audience either at the end of their presentations or at our larger Q&A at the end of both presentations, where we have a little bit of free time to go through audience Q&A. Science at Cal, I don't want to move on to our speakers until I just mentioned that Science at Cal celebrates the wonder and excitement of UC Berkeley STEM research. We bring that research to the community with programs like this, our partnerships with Berkeley Lab, our programs that feature graduate students and faculty members, and of course, our amazing postdocs. All of our events are free. They're open to the public, and they're really meant to be geared towards public audiences, not sharing science with already the scientific community, but with all of you who are excited about all the things that are going on at UC Berkeley and beyond. And right now, I'd like to pass things over to Jen Tang from Berkeley Lab to introduce who they are.
Awesome. Thanks so much, Dee. As Dee said, I'm Jen Tang. I'm the Director of Community Relations at Lawrence Berkeley National Laboratory. As folks might know, Berkeley Lab is one of 17 U.S. Department of Energy national laboratories across the country. And Berkeley Lab is supported by the Department of Energy's Office of Science, and we're managed by the University of California. All of the research we conduct at the lab is unclassified. And since our founding in 1931, by a UC Berkeley professor named Ernest Orlando Lawrence, Berkeley Lab has been dedicated to advancing the scope of human knowledge and seeking science solutions to some of the greatest problems facing humankind. Today, Berkeley Lab employees are dedicated to developing scientific solutions to the world's most intractable energy and environmental challenges, helping train the next generation of scientists and engineers, and ensuring that those things happen in a manner that benefits everyone. Our main campus is located in the Berkeley Hills above the UC Berkeley campus, and our proximity to Cal and our close ties to the UC system create a really unique and synergistic environment for scientific discovery. A number of the lab's researchers are affiliated with one of the UC campuses, either as students, postdocs, or professors who have joint appointments at the lab. And of course, the lab enjoys an especially close relationship with UC Berkeley. Because of that, our institutions have joined forces to advance science across a number of frontiers. One of the main motivations for creating our Midday Science Cafe series is to share with you examples of that compelling and complementary scientific research from both of our institutions. And we hope you enjoy today's presentation on wildfires and public health. Now with that, it is my pleasure to invite our next speaker to the screen, Jacob Bueno de Mesquita, an environmental health epidemiologist. Now, Jacob has dedicated much of his doctoral and postdoctoral study to measuring modes of influenza transmission, characterizing viral shedding generated by breathing, and identifying contagious biomarkers. Earlier in his career, he trained in basic biomedical science and global health at Georgetown and joined the CDC as a public health associate, where he contributed to emergency preparedness, immunization programs, and clinical public health service delivery. He joined Berkeley Lab earlier this year as a postdoc in the Energy Analysis and Environmental Impacts Division to study ventilation and other engineering controls with the goal of mitigating pandemics, promoting well-being, and achieving greater harmony with the natural environment. With that, Jacob, let me turn it over to you.
Okay, thank you so much for the lovely introduction. And thank you for having me today. I am going to talk about using buildings to protect against wildfire health risks. First, I'll talk about exposure to wildfire smoke and what is in wildfire smoke, and then the health risks associated with that exposure and how buildings can help mitigate against that exposure. And finally, I'll talk about the characteristics of smoke-related health inequity at the population level. Wildfire exposures are intense, and they are also increasing in number and magnitude with climate change. So here we have a picture of a wildfire from 2018 in Butte, that sort of started in Butte County, California, known as the Camp Fire. And in this figure on the right, we see this signature of the active fire burning. And we also see this big cloud of smoke that is blowing across the land. And in the figure on the left, you can see that that smoke is reaching the San Francisco Bay Area and reaching millions of people. So while the fire was intense where it was burning and it burned many structures and 85 people were killed, the smoke released from that fire is affecting millions of people as well. This is a picture that is showing the flow of smoke from wildfires across the country. This picture came from July 20th of this year. And at this point in time, I was actually living in Rhode Island over here on the East Coast. And I remember being told that we were not supposed to go outside and engage in strenuous physical activity because the air quality was not good, because of the movement of smoke from these wildfires in other parts of the country. So we have the source of the fire and the movement of the smoke across large populations of people. But during these smoke events, we're often told to remain inside buildings for the duration of the smoke event. And people actually spend most of their time in buildings anyway. And so the exposure that we're getting is mostly happening when we're inside. And if we are able to be inside during a wildfire smoke event. And so that exposure is coming through the building in what is called air infiltration from the outside into the inside environment. And this figure is showing different places in a building where air can come from the outside in. It can come through cracks in floors or walls or in the ceiling or around windows or doors, and can even go through ducts or fireplace or plumbing. In commercial buildings and multifamily residences where air is being drawn in from the outside, smoke can also get in that way if it's not properly filtered by those air intake systems. So the health risks are severe from wildfire smoke exposure. And I want to just talk here about particulate matter, which is the main a component of wildfire smoke, and particulate matter can come in different sizes. And the size of the particulate matter, or the PM, it determines the severity or of the health effect and the type of health effects that arise. And so we have here this PM10 or 10 microns. It's the larger particles. They get stuck in sort of the upper respiratory airways, and they don't get down to the lungs, but the PM2.5 and PM1 and PM0.1, these smaller particles can penetrate deeper and deeper into the lungs. And these smallest particles here, these ultrafine particles, which we know that wildfires produce many of these particles, they can reach directly from the lung into the bloodstream and cause inflammation and both respiratory and cardiovascular diseases. And these are, as well as inflammation, sort of systematically, as well as in the respiratory and cardiovascular systems. And so that can be a great burden on health. So one last point about exposure is thinking about what is actually in a breath of smoky air. So I just told you about particulate matter at those different sizes. And for reference, this is a illustration of human hair. So you can see that the PM2.5, PM10 is much smaller than the diameter of a human hair, and the PM2.5 is even much smaller than that. And so this generally for wildfires is made up of the burned vegetation or trees or grasses that are burning as part of the fire. And there are also gaseous pollutants that are invisible to the eye that are major components of wildfire smoke, particularly close to where the wildfires are burning. And this creates a bit of a toxic soup, which is really not good for humans to be inhaling. So exposure is worsening with climate change. Here we have a model of what wildfire PM2.5 will look like as we move across the century. So in the year 2000, this image on the left is showing the concentration of PM2.5 from wildfire smoke. And we can see that that concentration is increasing over time. And this is sort of on our current trajectory with climate change. So I mentioned some of the health risks, but I wanted to also share this figure about all-cause mortality and cardiovascular mortality and respiratory mortality. So these plots are showing on the x-axis the wildfire-related PM2.5 concentration and the relative risk of either all-cause mortality or cardiovascular mortality or respiratory mortality associated with those exposures to the concentrations on the x-axis. And what you can see here is a positive relationship between the concentration and the risk. The higher the concentration we're exposed to, the greater the risk. And so the dose really makes the poison here. And the point that I want to make is that reducing any exposure to this wildfire-related PM2.5 can really reduce the relative risk for these severe outcomes. And also, interestingly, SARS-CoV-2 risk of infection and hospitalization has been linked with exposure to wildfire smoke and increases in particulate matter. So here's one of the main points of the talk, is that buildings can actually protect us against exposure. So this is a good thing. And here's some data that I wanted to share from a study that happened at the UC Berkeley campus in 2018 related to that campfire that I showed you a picture of earlier. Scientists outfitted two buildings, this Worcester building here and this building on 4th Street here, with air quality sensors that were detecting particulate matter 2.5. And the interesting thing about these buildings is that this Worcester building has a very high infiltration rate, meaning that there is a lot of air from the outside can get into the building. That's because it has a naturally ventilated wing, and that's just based on its construction. It has this high infiltration rate. On the other hand, this building on 4th Street is mechanically ventilated with filtration of that air that's coming in from the outside. And what the scientists found was that during this campfire event in November of 2018, this building with the low infiltration had PM2.5 levels below the WHO recommended values for PM2.5 indicated by this red line, whereas inside the building compared to outside. Meanwhile, in Worcester Hall, those levels inside the building were much higher and above the recommended levels. The researchers also asked the people in these buildings whether their workplace, to what extent their workplace influenced their ability to get their work done. And they found that during a typical time without wildfires, the buildings were pretty similar in terms of the response. Many people said that the building somewhat interfered with their ability to get their work done, their productivity. But during the wildfire, this is the interesting point, the group in the Worcester Hall had a much higher rate of respondents saying that the building somewhat interfered with their productivity. And this was much higher than in the 4th Street building. So the main point here is that this high infiltration here in this building is likely associated with both the PM2.5 levels in the building and this impact on the productivity. So the main ideas with buildings as protection are that buildings can limit the infiltration if we seal them properly of the outdoor air into the inside, and it helps to have cooling inside your building. Structures that don't have cooling systems, people often open their windows to bring in cool air, and so that can be one thing that can help. Is to have a cooling system and then seal the building. And then to also filter air properly. And by properly, I mean by using a MERV 13 filter or higher, and to filter the air both in either HVAC systems or by using portable air cleaners in your building. And this figure over here is from a study that was done that actually tested the use of a portable air cleaner which was actually a do-it-yourself air cleaner, a box fan with a MERV 13 filter strapped to the back of it. This filter was shown to actually dramatically reduce the PM 2.5 levels indoors. And then the other thing is to limit indoor sources of pollution while you're inside hiding from a fire, wildfire smoke. And so that means it helps to not smoke indoors. It helps to not vacuum or cook with a gas stove, for example. So here's one of the last points that I want to make is that there are inequitable health risks from wildfire smoke. And this plays out on because of two main features. One is the level of exposure that population gets to the wildfire smoke. And this has to do with the proximity to fires, maybe your ease of relocating out of a wildfire smoke zone, outdoor work exposure, but also the level of building leakiness, that infiltration that I talked about, and the amount of filtration in a building, either home or workplace. So the other main factor that contributes to inequity is the level of existing health burden. So that could be a level of asthma in the community, COPD, respiratory diseases, and other health conditions, as well as harmful environmental exposures and stresses, and access to quality healthcare. If you think of these existing health burdens as filling up a cup, and humans, we can only take so much burden in their cup. When the wildfire exposure comes, that cup is going to overflow, and those respiratory and cardiovascular diseases, heart attacks, strokes, and other adverse health effects are going to happen. And this is playing out at socioeconomic levels, between rural versus urban settings, among different racial ethnic groups. Studies have shown that Black and Native American populations have faced the brunt of wildfire-related inequitable health risks, as well as age, sex, and gender. And Stephanie's going to talk more about the effect on children and what that means. But the main point here is that by focusing on our buildings, we can reduce some of this inequitable health risk. We can sort of reduce that cup from overflowing by reducing the exposure to wildfire smoke when those wildfire smoke events are happening. So thank you.
Fantastic. Thank you so much, Jacob. That was a wonderful presentation. And before we turn it to our next speaker, we'd like to ask you a few questions.
Okay.
Yeah, so first, who determines the national standards for air quality and how are they derived?
So the we have national ambient air quality standards set by the EPA as part of the Clean Air Act. And here in California, I know the California Air Resources Board is also involved in setting some standards. Generally, people look at the sum total of the evidence that is relating exposure to health outcomes and sort of setting. Generally, these studies are large-scale epidemiological studies that have measured exposures and outcomes in population, and that is what's sort of driving the determination of these different levels of exposure that could be deemed acceptable. I would note that there aren't any indoor air quality standards, actually, which may be something of greater interest as we move forward. And so this is why it's really important to keep our indoor environments clean, especially when we have a threat of pollution from an outdoor source, such as wildfires, or in highly polluted urban settings as well. because we spend most of our time indoors, actually.
Thanks, Jacob. Let me ask you one more question. Why is public health information and data so focused on the 2.5 micron size for particulate matter? You showed in your slides a 0.1 micron size particulate, and that can lead to much more serious disease, right?
Yes. Well, so the PM 2.5, it does include the particles that are smaller than 2.5. And so it includes those small particles as well as the particles that are above 1 micron in size. And that's sort of traditionally been a cutoff of the size of particles that we know that can penetrate deep into the lung. And cause all sort of respiratory and cardiovascular effects. It's the same also for SARS-CoV-2 transmission that we're talking about, these aerosols now that can be inhaled. And so it's really that sort of size fraction of aerosols that is driving a lot of the health risk, both for the smoke as well as for respiratory infections.
Got it. Thanks so much, Jacob. And we appreciate those answers. Now, let me actually turn it over to Dee, who's going to introduce our next speaker.
Yeah, that was wonderful. Thank you so much, Jacob. So I will hand things over to Dr. Stephanie Holm, who received her medical degree in 2011 from the University of Pittsburgh and is board certified in both pediatrics and occupational environmental medicine. She trained at Children's Hospital and Research Center Oakland and the University of California, San Francisco, respectively. She also completed a year of pediatric pulmonary training in Oakland before leaving to further pursue interest in pediatric research and pediatric environmental medicine. As part of her work with the Western States Pediatric Environmental Health Specialty Units, she has reviewed literature relevant to disinfectants in early care and educational environments and related to wildfire smoke exposure, which is why she's here, right? Dr. Holm completed a Master's of Public Health in Epidemiology at UC Berkeley in 2017, and then a PhD in Epidemiology in 2021 while continuing her research activities. So she's been all over the place. After all of those degrees, she is now with us today. So we're so excited to get her expertise in the next few 10 to 15 minutes and during the Q&A. So again, don't forget to add those questions in the chat and in the Q&A box. I will hand things over. Stephanie, take it away.
Thank you all for having me today. All right, I just really quick, before I dig into my lecture, I always have to give my little disclaimer, which is that I'm lucky enough to be funded by and employed by a number of different folks, Cal EPA, US EPA, Agency for Toxic Substances and Disease Research, and that in general, talks that I give are my own and not official stances of any of the various organizations that fund and or employ me. All right, so I actually really appreciate Jacob going first. He laid out some really nice groundwork for me. So he's already gone over with you guys why wildfires are important. You probably also already knew that, having just come and been here today. He went over what's contained in smoke, that it's largely particles of various sizes, but that it's also this, really complicated mixture of a whole bunch of different things. And then Jacob also talked about some of the health effects and that certain groups are at particular risk. As he mentioned, I'm going to dig into the health effects for kids, why kids are particularly susceptible. We'll talk a bit about how you can know if your air is bad, and then some more about what things you can do. Jacob already covered some of the indoor air material. We'll talk about some other issues. All right. So I always like to start with why are children more vulnerable to environmental exposures, actually generally, but for this specific case, we'll walk through it in terms of wildfire smoke. So the first is that kids have differences in their physiology that increase the relative dose that they get, increase the dose they get relative to their size. So for the case of wildfire smoke, kids have what's called a higher minute ventilation, meaning they breathe more air per minute relative to their size than adults do. And so that means that as they breathe in more air, they're also going to breathe in more pollution, breathe in more wildfire smoke relative to their size. The second is that kids have unique windows of growth and development. So I often like to joke that my 7-year-old daughter has changed much more in the last year than I have. And so, if you think about exposures that happen while kids are rapidly growing and developing, if you change not just something that's static in time, but you change the pattern of growth, right? You can change that growth pattern and then have long-lasting effects because of changes that happen during those periods of rapid growth and development. And then third is that kids have behaviors and preferences that increase their exposure to a lot of environmental exposures. So in the case of wildfire smoke, really the big issue here is that kids tend to be outdoors much more than we are and tend to be running around more than adults are. That's a good thing, right? We want to encourage our kids to be active. We want them to be spending time outdoors. But you breathe more when you're active and running around. And so you'll also get in more smoke. And then if you're outdoors, as opposed to in a nice indoor place filtered like Jacob told you about, or like myself sitting here next to an air filter that I keep by my desk, that child will get more exposure than I will. So for all three of those reasons, kids are particularly vulnerable. Jacob mentioned to you some health effects that we know about in general. This is my little summary slide I like to use for what we know specifically in children. And this comes from two different sources of literature, right? So there's a big literature set of scientific papers on health effects in children related to air pollution. So we know what the different components of wildfire smoke are, and we know what health effects those are associated with, even during non-wildfire times. And then there's a second, smaller but growing set of studies specifically looking at health effects during wildfire smoke times. So the most well understood is respiratory effects. And that probably isn't a surprise to maybe any of you on the call. What I would call upper respiratory or upper respiratory effects are things like itchy eyes, scratchy throat, runny nose. Those are probably all the things that you would expect happen when you're exposed to smoke. And we have good data to show that that happens with kids as well. There are also lower respiratory effects. So that's things like increasing asthma symptoms, as well as infections like pneumonia and bronchitis. Those things increase during wildfire smoke times. So there's lots of wildfire specific data there. For these other things that I have on the slide, much more of the evidence comes from what we know from non-wildfire times. We know that particulate matter is associated with metabolic and growth changes in kids. So things like higher BMI is associated with pollutant exposure. There are neurocognitive changes. So that's things like attention, increasing ADHD, also decreases in childhood IQ. Particles are a known carcinogen, right? There's an international group that classifies chemicals as cancer causing, and particles are known to cause lung cancer. So we would certainly expect that particle exposure in childhood could contribute to that lifetime risk of cancer. And then both from studies during non-wildfire times and wildfire times, there's starting to be a few looking at birth effects. So the chance of being born small or being born early when the gestational parent is exposed to wildfire smoke during pregnancy. So really wide-ranging effects, enough for us really to be concerned, right? And enough that I, as both a pediatrician and a parent, am really worried about this generation of kids that is growing up with wildfire smoke events as sort of part of their frequent milieu, right? Frequent things that are happening in their life. All right, so let's talk about how you know if wildfire smoke is a problem. Many of you may know this already, but I always like to just sort of start, do, re, mi, start at the very beginning. For air quality, that's the AQI. And so this AQI scale is put out by the US EPA. Starts with green for good, yellow for moderate, orange is unhealthy for sensitive groups, that includes children, red is unhealthy, and it goes up from there. I like to make the point that this is really evidence-based. So the US EPA spends a lot of time looking through the entire body of scientific literature to set their standard levels. And those standards are set to be the level at which human health is protected, including health for sensitive groups. The cutoff between moderate and unhealthy for sensitive groups is that standard. So this AQI scale is really based on a lot of scientific information and is reviewed periodically by the EPA to make sure it stays current. And those levels can be changed. They have been changed, over the last 50 years since the EPA first started doing these. All right, so how do you know what the AQI is near you? If you or someone in your life wants just sort of a simple one place to look, get a straightforward answer, this is where I would point you to. This is www.airnow.gov. There's also an AirNow app if you'd prefer to have it as an installed app on your phone that shows very similar information. If you type in your zip code, so you can see at the time I did this last fall, I typed in the zip code for San Francisco. The air quality at that time was good. You've got this little odometer kind of reading thing over on the left that shows you what the current air quality is using those AQI scales we just talked about. If you ever forget what those are, there's this little AQI legend over at the left. You can always click and open that back up. It'll also give you a forecast for what the general level is expected to be the next day. So you can see at the time I took this, the following day was expected to be a little bit worse. I will say, however, folks that are really into data and into science, which might be all of you who chose to tune in for this call, sometimes find this frustrating because they don't think that this information is granular enough. There's not enough detail here. And so if you're one of those people, I would suggest that instead you use this page, which is fire.airnow.gov. It's also a US EPA page, but it has a map that shows you more information. And what's really cool about this map is that it integrates multiple sources of information. So these circles are the same high cost, expensive, state-of-the-art governmental monitors that report data for that AirNow page we were just looking at. But in addition to that, it includes information from lower cost sensors on this map. And that's what these squares are. The third thing, and I actually realize I don't have a picture of it in this image, so I apologize, but there are highly expensive, but mobile stations that sometimes get moved around during times of fires. Those are triangles. Those also get shown on this map. And then these get color coded based on that same AQI scale, right? So green for good, yellow for moderate, orange is unhealthy for sensitive groups, red is unhealthy, and purple is very unhealthy. I got really excited the day that I saw this map because I was like, I can get all of the colors or almost all the colors in one shot so I can show people. It's what excites air quality nerds. What can I say? But anyways, the nice thing about this is you can use this kind of map and this kind of spatial variation to make some decisions for yourself. Like, for example, if you lived in Chico at the time I took this picture and you were trying to decide, where do I take my kids to the park? You could see that the air quality was clearly better on the west side of Chico than it was on the east, right? And certainly for folks that live in places like the Bay Area or down in Los Angeles, there's sometimes even much denser networks of these monitors. And so it can give you pretty granular information about what things are like in your area. One of the nice things about this map is that the EPA does do some quality control on the low cost sensor information that comes in and also applies the best available correction factor. So you're getting the best possible information. Sometimes folks wonder about sort of minute-to-minute information. The best way to do that is on this map. If you click on a specific sensor, it'll bring up more detail. I'm not going to run through all of these just for time, but whoops, one thing it will show you is what the current trend is. So it'll show you over the last 30 minutes what's happening at that sensor. So for example, you can see at this sensor, it was orange, unhealthy for sensitive groups, but it was getting worse, right? This shows you that over the last half hour, it was increasing towards the unhealthy range. So that's helpful if you're making decisions like, do I go for a run now? Do I take my kid outside now? Do I open my windows now, right? It gives you that sort of moment-to-moment information. All right, once you know how what your air quality is like, then you can think about what kind of things can you do. Jacob did a really nice job talking about some indoor air interventions. One thing that I always just like to make sure people understand is the difference between ventilation and filtration, right? So ventilation is really important for exchanging air, for decreasing air pollutant levels from indoor sources. Filtration is really important for filtering contaminants and decreasing air pollutant levels for both indoor and outdoor sources. I have some studies mentioned down here at the bottom, and I actually want to point out these are non-wildfire times. This is just during, regular school year, other times of the year. Both ventilation and filtration have been shown to be related to improved both health and learning benefits for kids. So things like decreased absences due to illness, decreased asthma symptoms, improvements in test scores and math and language performance. So there are real benefits to having these interventions even during non-wildfire times that of course get magnified during the wildfire smoke events. And I think, it really makes the point that schools are a unique place where we can intervene and affect lots of kids. All right, so since Jacob spent a while on indoor air, I thought I would do a little bit on masks and respirators. So if we're thinking about mask and respirator use for wildfire smoke protection, that's different, of course, right, than the COVID-19 scenario. So we're going to set COVID-19 aside for a second, although I'm happy to answer questions about both if folks have them. But thinking about protection from wildfire smoke, we're really just thinking about something that's out in the world, and I'm trying to protect myself or my child from that. And so with that scenario, there are two things you want to think about. You want to think about filtration of the material, how many particles can actually pass through the material of the mask or respirator, and then leakage, how many particles can pass around the edges of the mask or respirator. Because of this, cloth face masks like you use for COVID, those really aren't regulated for their filtration capabilities or their leakage, right? Sort of how much can come around. And so those can't be depended on for wildfire smoke. Instead, what you'd want to use are either things like medical masks. Those are those pleated, they often have ear loops, non-woven masks, or a NIOSH certified N95 mask. So the medical masks, the material is regulated, but the fit is not. NIOSH certified N95s both are actually regulated, both material and fit, and that's why you can get better protection from those. This graphic is showing that if you look on our AQI scale on the left, if you're in a day that is in the unhealthy range, because medical masks can be expected to decrease your or your child's exposure about 20%, that'll decrease the level that you're getting, but you'll probably still stay within the unhealthy range. If you're at the very bottom of unhealthy, you might be able to get down into unhealthy for sensitive groups. In comparison, in that same unhealthy day, wearing a NIOSH certified N95 mask, you would expect that you'll decrease your exposure about 80%. Why 80 and not higher? If you're someone that wears an N95 for work, you might know that that decrease is expected to be even higher. If we're using it as the general public, right? If you or I are using these, we haven't been fit tested. We're not part of a workplace program. And so the fit is often not quite as good. There's a little more of that leakage. And so that would be expected to be the case for you or your kid. Definitely the more you can do to try and make sure you're getting a good fit on those, the better. Unfortunately, at this point, N95s are not manufactured for kids in this country, but many children, especially sort of school-age children and above, can fit small adult size NIOSH N95 respirators. And so it's a bit of a challenge, but certainly worth trying different kinds to figure out what fits best for your kid. I actually just went through that with my daughter, who's, as I said, is 7 and have one that fits her well. Really quickly before I wrap up, I just wanted to point you, when I was introduced, Dee mentioned that I work at the Western States PACU, that's the Pediatric Environmental Health Specialty Unit. We have a lot of resources available for folks, both for healthcare providers and the public, infographics and fact sheets and all kinds of stuff available on our page there. We also tweet about wildfire stuff pretty frequently because we do a lot of wildfire work. So I've put our information up there in case you'd like to see that and pull any of the graphics that I've shown today or share them with anybody else. I'll just wrap up with this one, which is my sort of summary graphic for how to reduce wildfire smoke exposure for kids. The best ways to do that are to do one of the things in this top row. So either to be somewhere without smoke, and when that's not an option, to go indoors with good filtration. So that's either using HVAC with a MERV 13 rated filter or higher, like Jacob talked about, or a portable HEPA cleaner, making sure you're getting one that's the right size for your space. You want to make sure that you're getting one that's a mechanical HEPA filter based, not electronic ones. And then the other is to go inside and shut the windows. You will get some decrease, but much better if you have filtration. For short periods of time, you can also recirculate the air in your car so that you're getting filtration from that. Or you or your child could wear a small size NIOSH N95 mask or wear a medical mask. I will wrap there so we can get to some questions. Sorry, I get excited every time I'm doing this topic and I could just keep talking forever.
No, we love that. This is all amazing. Very, very good information. I know we had some people asking about how N95 masks aren't made for child faces. And you mentioned that also. So really, how can we make sure that the masks and all kinds of masks are actually fitted properly?
Yeah, really good question. So I actually have a slide that I can share with you about here. And this is available on our webpage as well. I mentioned the Western States PACU page, and I think it was going to get dropped in the chat in case anyone wanted to see it. We have this graphic about how to do a seal check with your kid. So when you have them put on an N95, to sort of cup your hands around the edge and have them do a big blow. I often say like blowing out birthday candles, and feel for leakage around the edges. And then have them take a deep breath in, again, feeling for leakage around the edges, and you should also see the mask compress towards their face slightly. If you feel any air moving, you want to adjust and try again. Particularly feel up here around the nose is a common place, here and under the chin. I saw someone asked in the comments which mask worked for my kid. I don't like to recommend specific products because everybody's face is different, but I will say one thing that I found really helpful for my kid when trying to fit her was, instead of trying to buy the ones that have a rigid structure or a rigid shape, there's some of the N95s that are either like duckbill or sort of flatter fold that are more of a flexible shape. I found that made it much easier fitting my daughter's narrow little chin.
Yeah. And you had mentioned to me, because I was about to board a flight last week, that this is something you should do to yourself too, right? Not just kids, but, and I did practice, and I started looking at folks around me, and I could see their masks sucking in when they breathe. I was like, your mask has a good fit.
Yeah, no, exactly. It's really good to know. And I think, sometimes people hope that these masks are a little bit magical, right? That just like having it nearby helps. I remember one time during a wildfire event, this is back, pre-COVID, I was getting off BART, and there was someone with a big, huge sort of Bay Area style beard with an N95 perched delicately on top. And I could literally see into his mask as I walked by. And, you're just really not getting much benefit from that, right? It's the filtration and the fit that are important.
Right. Thank you. Any other advice for caregivers, so parents or teachers, about protecting children that you just want to go over quickly?
Sure. I mean, I think overall advice for parents and children is that indoor air is really important. And so the more that you all can advocate for safer indoor air spaces for your kids, the better. I'll also just show that we have this graphic. Oops. Wrong one. This graphic on our webpage that has just some safety guidance to think about for masks, making sure that if you're going to use a mask, that's really any kind of mask or respirator for a child, that you're using it with a kid who's able to tell you if they have problems, right? Your stopgap measure is if your kid says they have a problem, you take it off.
Great. Okay. Thank you so much. We want to make sure our kids are safe for sure. So Jen and Jacob, why don't you rejoin me? I know there's a lot more questions for Stephanie, but I want to make sure there was a lot of questions for Jacob as well. So let's start getting through those. Jen, do you want to take it away with a question?
Sure, definitely. And let me just thank both Stephanie and Jacob one more time for their great presentations. So let's start with this question. And I think this is something that is probably relevant to all of us. There are a few folks who live in part of the Bay Area that's really hot during the summer. Now, if the air is rated moderate, according to airnow.gov, how should they think about keeping their windows open? Should they keep their windows open? Should they keep their windows closed and only use air conditioning? I think people are interested in learning a little bit more about what the health risks are for both adults and children, and whether it's okay to open the windows when the air is moderate. I guess that's maybe a question for both of you.
Sure, I'm happy to take that first, and then you can certainly jump in, Jacob, if you've got other things to add. I would say two things to think about. So one is that, the EPA has tried to make this scale so it's easy to understand for folks, but this is a continuous scale underneath, right, that we're thinking about. And so just like if you think about heat waves, right, that like how much of a problem you're going to have changes as the temperature goes up. And it's not like I can say like 96 degrees is absolutely fine, but 97 is a problem, or 97.1 is a problem, right? It's a continuous scale underneath it. The AQI is the same thing, right? And there's health effects that can be seen even at low levels, but it's more of a problem the higher you get. So I think keeping that in mind is a helpful frame. That being said, the EPA has set that level so that 100, the cutoff between moderate and orange and unhealthy for sensitive groups, yellow and orange. Sorry, I'm mixing colors and category names there. That cutoff is based on the level in which they expect it to be health protective for even sensitive groups. So I think, certainly if it's a kind of day where it's otherwise always been green and there's 1 hour of moderate, then maybe you don't open the windows during that 1 hour of yellow moderate. right? But if the air quality has mostly been orange or red, and now you have an hour of moderate, that hour of moderate's a great time to open the windows because that's the lowest time you've got during the day. So it, I think that's what makes it a little bit challenging, especially for folks that might not be as used to looking at data, is that it's not like a simple, this level is absolutely safe and this level is absolutely a problem, right? I can't give you that sort of exact point at which you're 100% safe or 100% concerned.
Yeah, there was a question that's similar to what you're talking about that said that the school added a MERV 13 filter and also maximize the intake of outside air via the HVAC for coronavirus purposes, right? So there's this, at what level of pollution smoke should they then switch to recirculating the air, even though coronavirus is afloat? So is it moderate? Is that considering coronavirus precautions?
So I'm happy to take this too, unless Jacob, you feel like you've got something you want to say. Sorry,
Go
I do
ahead,
a lot
go
of
ahead.
wildfire talks. So I generally like to say to folks that I think there's a bit of a misperception that coronavirus and wildfire smoke are at odds with each other. What people think is they're like, oh no, there's wildfire smoke. I want to shrink wrap my building and prevent anything from coming in from outside, right? That's sort of the gut reaction. And the problem if you do that is that you have any kind of pollutant that's produced indoors, and I'm using pollutant really broadly here, that includes things like coronavirus, right? That people are exhaling, but also like if you are doing art projects with kids and you have volatile organic compounds coming off the art supplies, or you're running a wood shop, or any of these other things that could be produced indoors, you can have problems with those if you really seal down the building. So the reframe that I suggest is to really think about filtration, right? That as Jacob was saying, filtration is the really important key. And so if you have a really good filter and you've bought extra filters to have them on hand so that when your filter gets clogged, you can replace it, then you can still bring in that outdoor air. You're filtering it before it comes in.
Yes, and the portable air filters can also be really helpful here if you don't have an HVAC system with the filter included in your recirculating system. Another approach for schools that we've been discussing with some districts is using upper room germicidal UV, which also doesn't rely on outdoor air to be very effective, and actually can even work better with limited air exchanges.
Can I add one caution about that though, Jacob? I know of at least one school district nationwide that spent a lot of money to install those. And then because of malfunctioning UV systems and children getting burned, they had to rip them back out. So that's something that I get really worried about in school settings.
Well, if it's done properly, they are very effective. Yeah, and I mean, I know of other school districts that have implemented them with great success.
For sure.
And in terms of COVID control, you can get the best amount of air sanitization from germicidal UV units. Yeah, definitely must work with someone that knows what they're doing when you're installing the systems, but I wouldn't throw that solution out the door because they were implemented improperly in one place.
Thanks both. Those are super helpful answers. Since we're talking about sort of filters, I'd like to ask this next question. I think, again, both of you probably have interesting perspectives. So are there any studies that measure the relative effectiveness of like a DIY box fan paired with a MERV 13 air filter versus maybe some of the more commercially sold HEPA filter fans or air filters?
Yes. When those do-it-yourself box fan filters are done correctly and sealed up correctly, you can get a greater clean air delivery rate from those units compared with many of the other commercial air units, and they are much cheaper as well. One problem that people come up against is the sound. produced by them. Like, for example, I spoke with a professor that tried using one in a classroom the other day, but he was able to turn down the speed of the fan, and that worked well for him in terms of reducing the noise.
I think the other keys, if people are going to do those, is you want to make sure you're using a modern box fan. So ones that were built in 2012 or later. And that's just from a fire safety perspective. They have a different kind of fuse in them. But I think one thing I often, and maybe you know more about this, Jacob, than I do. One thing I often say about those, we know that they're really effective in the short term. There's not, that I know of yet, a lot of data on sort of the longevity of those devices and how long they'll actually last and work for people. So I think that's one thing to consider if you're thinking about that, as opposed to a commercially available product.
Great. Thanks. Oh, Dee, do you want to ask the next question?
Oh, I just want to be clear, because somebody also did ask this question. I thought, oh, maybe that's not totally clear. Indoor electronic forms of indoor air purifiers also filter out smoke from the outside if it comes in, correct?
So there are like ionizing air filters that are sold for, and I'm going to put in air quotes, air purification. I put that in quotes because purification is sort of a funny term, but I actually recommend people avoid those. There's two reasons for that. One is that many of those produce ozone, which is in of itself a pollutant, right? That's a respiratory irritant. It can irritate people with asthma. So that's also a problem. Even the ones that don't produce ozone produce negatively charged ions that go into the air. And there's starting to be some data, this is more limited, but starting to be some data to suggest that there are health effects associated with those ions as well, that may actually counterbalance some of the benefits from the air filtration. And so since we know we've got these mechanical HEPA filters that work well with little in the way of risks, I suggest that people stick with those.
Perfect. Thank you. Jen, go for it. And I feel like all of these questions could go either way. So it feels like, oh, we'll just bounce back and forth.
Yeah, so, this was a question that I actually had myself, and I'd love to hear from you both. Somebody asked about what your thoughts are on purple air sensors. They're quite prolific, but AQI figures from the Purple Air website typically seem to be about 25 to 30 degrees above the government air now readings. So can you talk a little bit about that?
Sure. I actually have a slide I can pull up to tell you about that if you'd like. So I get asked about purple a lot. And I think there's two main things to think about when you're thinking about low-cost sensors. So the first is how well those track the gold standard ones. And then the second is whether there's a correction factor that's good. So purple, this is what purple's map looks like. Again, not endorsing them, I just include it because I get asked about this a lot. You might notice I actually took this screenshot from purple at the exact same time that I took that screenshot of the fire.air now map that I showed you earlier. So this is showing at the same time. So there are a few things that I think are problematic if you're using the purple map. One is that the default is purple's own correction factor is much less accurate. Without going into a whole lot of detail, the low-cost sensors mostly count particles as opposed to measuring mass. And so they have to do some kind of calculation to change that count into a mass. And particularly at high levels, purple's is known to be pretty inaccurate. There is a US EPA correction factor. You can change that by clicking here and changing it to the US EPA factor. So that'll help. That'll change the correction factor. There's less QA, less quality assurance done on the purple map. So when monitors start misbehaving, they still show up on the purple map and are taken down much more quickly off the US EPA one. The averaging time is shorter. That's a problem for a couple of reasons. One is that it means that really quick fluctuations in the levels get picked up on this map. So if like a delivery truck is idling in front of my house and I have a purple air monitor, it's going to pick up that truck idling for a couple minutes. That's a real thing it's measuring, but that doesn't necessarily mean that my neighbor down the block or 3 blocks away that's looking at my purple as a sense of what's going on in their neighborhood is seeing that level that it's picking up, right? So having the longer averaging time smooths out that variability a little bit, but also most of the health effects data that we have is actually for longer times. So it gets increasingly hard to really make health guidance for the shorter times because we just don't have the studies to back it up. And then the last one, this is kind of a minor thing, but the colors are less perceptually uniform. So this bugs me about this map. This, for example, this 92, to me at least, that looks pretty orange already, even though ostensibly you're still in the moderate range. You're still in the 50 to 100 range. And so I think that in addition to the numbers being different, the colors also make this look quite different for people.
Thanks, Stephanie. Jacob, anything you wanted to add to that?
No, I think that is a great summary of it. Thank you.
And probably for either of you, do you know have any studies that have been done on air filtration in cars in case somebody needs to be in a car for long periods of time, and as it relates to like during wildfire season or not during wildfire season, right? Because we were also thinking about cars as a space of sharing coronavirus as well, right?
Yeah, so I don't know of specific studies, and maybe you do, Jacob. The advantage of using a car for a short period of time is you can recirculate the air, and so whatever filter you have, you're running back through the filter. The problem with doing that for a long period of time is that CO2 that we breathe out, when that gets to high levels, you can get things like headaches and other symptoms that you won't feel very well, and so you don't want to be doing that for a long period of time. I know that more modern cars have higher quality filters, but I don't know of specific data on exactly the levels of reduction based on different kinds of cars. Do you know any of that, Jacob?
No, it's just I would keep the recirc on and not go for a very long distance. Or
Yeah.
it could be that you could, lower the window for a little bit to get, a bout of fresh air in, and then keep doing the recirc.
But I think the other thing is if you don't have a safer indoor space to be in, right? If you're someone that's living in your vehicle, for example, that would be the time that you want to find a cleaner indoor air shelter in your area. When these events happen, smoke events happen, there are air shelters that get opened up. I'll be honest, I think it's a little inconsistent right now how people can find out about them, and I wish that was better. I know there are some folks working on that at the state level, but certainly knowing what the local air district is where you live. So here in the Bay Area, that's the Bay Area Air Quality Management District, BAAQMD. Apologies for the acronyms. But often those air districts have information on their page about where you can find out local clean air shelters, as well as local news groups, right? Your local news station or news webpage.
Great. And how can one measure indoor air quality? Somebody said either commercially or residentially.
I guess this is probably about using consumer grade sensors.
That's what I would imagine. Yeah.
Yeah. So there are more and more consumer grade sensors now available for use. And even getting a purple air sensor is one thing that you can get for either your indoor or outdoor environment.
Or both.
Yeah. And then you can be another dot on the map if you choose. I use a sensor for CO2 as part of my sort of COVID indoor environment work. But yeah, there are a variety of these sensors, and they're becoming more and more accurate too as we go forward.
I think the best way, if you want to know which ones are really good to use, there's a website called Aqi Spec. I'll put this in the chat box. You know what, let me double check and make sure I get it right. But this is, it's out of South Coast Air Management District, one of those air management districts I was talking about a minute ago. And they do third-party evaluations of low-cost sensors. So if you're the kind of person that likes looking at data, they'll evaluate a bunch of these, and then they can report the R-squared value. So if you remember back to like basic statistics, if you ever taught that or took that, that's the, or taught it, I guess, that's the relationship from one variable to another. And so just like I said before, you want to know that the monitor that you're using goes up and down, sort of related to the gold standard monitor. That's what that R-squared value is telling you. So you want to look for one with an R-squared close to 1. There's still that issue of the correction factor, but if you're using it to trend, and that's why I somewhat flippantly, but truthfully said when Jacob said, or I said you could do both, is because then you can look at what your outdoor and indoor is compared to each other. And then the correction factor doesn't matter as much because they're both doing the same thing, right? So you can just look at, oh, this is this much lower than what's outdoors right now.
thank you so much for that site, because we had so many people asking for product, but you said you don't like sharing products. So I wasn't going to ask those questions, but a website that is doing that for you, essentially that evaluation, is exactly what we needed. So all those folks who asked for actual recommendations, there you go. And just to be clear, Jacob, measuring the CO2 essentially is measuring the freshness of the air. Is that correct?
So the CO2 level indoors is used as a marker of how much air you're inhaling contains exhaled breath from people in the room. Outdoors, the CO2 ranges from about 400 parts per million to 450 parts per million. And then indoors, you'll see that as you approach that 400, 450, that's almost all outdoor air. But humans produce 38,000 parts per million in our exhaled breath. So if there's a person in an indoor space, that level is going to start increasing. So it gives us a good estimate of your exposure to exhaled breath from other people in the space, essentially.
Great. You had mentioned the CO2 sensor, so I wanted to make sure we honed in on why you were using that, and that makes sense. All right, so Jen, over to you.
Thanks so much. So, we've talked a little bit about filtration inside. Can you talk a little bit about maybe some other measures we can take to make sure smoke doesn't come inside the house? Is it recommended that you put things like duct tape around windows, or, what other actions can you take to make sure smoke's not coming inside?
Let's see. Stephanie, do you have something to say on this? I know that Elliot Gall, who's a great air environmental engineer in Oregon, has produced something about this. But I know one of the things you can do is create a sort of a safe room in your building, where you put an air filter in that space, a portable air cleaner, and then you seal it up. You tape up the cracks, and also the window around the windows and the doors as well, outside of that room. And so that can be sort of one solution. Maybe Stephanie wants to elaborate.
Sure. Yeah. I mean, I think so. Certainly, creating a cleaner air space is one option. There's a nice CARB infographic about that. This is off CARB's Twitter channel, but I'll drop it in the chat box if people want to see it. Certainly that's one good solution. I think in general, though, I often just say to really focus on the filtration piece, right? If you think about, there are three ways that air can come into your home. One is through HVAC, right? Like if you have an HVAC system, that's your mechanical ventilation. One is natural ventilation, that's opening doors and windows. And the third is infiltration, right? Getting in through the cracks and crevices and all of that. And if you think about that, these are the three ways air gets into my home. I want to filter that air as much as possible, right? So if you have HVAC, that's putting a MERV 13 filter in that, and also using a portable air filter. The more that you can filter that air, the better. And then you have fewer issues with mold and moisture and, collection of pollutants that are produced indoors. So it's really, it's shifting that balance of like making sure the majority of the air coming in is filtered air.
Great, thanks both. Here's another question for you both. And this is back to looking at longer term exposure to moderate AQI. Are there any effects if you're, let's say, exposed to moderate air quality for a long period of time, especially, this time of COVID with schools having to keep their windows open, having classes outdoors, things like that?
So this gets a little bit tricky, and it depends a little on how much you really want to dig into data. But here's what I would say. Am I worried for my individual child, even if her classroom has windows open all the time and it's sitting in the moderate range? No. So to that extent, I think you can feel reassured. You don't need to worry for your kid at that moderate range. Are there any health effects, though, is actually a bit of a different question, right? And so when we look at things on a population level, things can change little amounts overall, and it affects things on a population level that may not have an effect for a specific kid. So an example, this is going a little bit outside this talk, but if you have a distribution of IQ levels, for example, something that changes the average level by like a third of a point or half a point. For a single kid, doesn't make any difference. You probably can't even pick that up if you tested them, because that's within the range of the variability on the test, right? But if you move the whole population curve down half a point, you now have a lot more people that are qualifying for services, right? That are in that range of being severely affected. And for a single child, that doesn't make a difference whether your IQ is, 0.5 higher or lower, but sort of on the population level and how much those things cost us on a population level, it can make a difference. So coming back to your question, with long-term exposure in the moderate range, I'm not worried for my specific child, and I don't think you need to be either, unless your child has something very unusual going on with them. But am I worried about long-term exposures and that we need to make sure we're getting our air as clean as possible for our kids? Yes.
Great, thank you. That was wonderful. How about just specifically, I know there's been a lot of conversations as it relates to coronavirus, but K95 mask for filtering smoke. Same.
Really good. Really good question. Sorry, I didn't mean to cut you off, Dee. No, so I really recommend that people stick with NIOSH certified N95 masks. NIOSH certified N95 specifically, because N95 is not a protected term, right? So I could make something in my backyard and call it an N95. That doesn't necessarily mean it is, right? So NIOSH certified N95. The issue with the KN95s or the KF94s is the other one I often get asked about. These are products that are from other countries and have standards that are supposed to be similar to those standards for the N95s. The problem is that when NIOSH, and just to pause for a second, NIOSH is the National Institutes of Occupational Safety and Health. That's the group that has done the most work on respirators in this country because respirators have historically mostly been used by workers. Early in the pandemic, when NIOSH did evaluations of a lot of those KN95s, KF94s, a bunch of these other products coming in from different countries, many of them did not meet the standards they purported to meet. Meaning that even though the standard should be fine, they weren't actually meeting that standard. So there was sort of a problem with quality control of what is coming in. And in addition, I'll say the one big difference between those standards is that the NIOSH N95 standard has a fit component in it in terms of how well things are supposed to fit. The KN95 standard does not. And that's actually a big reason why, and probably all of you have noticed this, those KN95s, many of them are ear loop, and people are like, oh, it's so much more comfortable. And you're like, yeah, it is more comfortable because it's not holding it very tight to your face. And so you don't have a very good fit. And I think there are exactly 0 NIOSH N95 products that have ear loops for that exact reason. They have head straps so that they're getting a tighter fit. So A, the standard is a bit tighter anyways, but B, many of those international products that are coming into the US are not meeting the standards they're supposed to meet. And so you really can't rely on those. So I would really encourage sticking with the NIOSH certified N95s, and those are available now, right? For a while they weren't. And so then it was a bit of a different question, but those are available now.
Oh, I had no idea about that. So
that's the answer to the question you and I were talking about too, Jacob. I just hadn't had a chance to tell you.
Well, and I just want to reiterate that the fit is so important, and getting the seal around the face, because you can have a great filter on your mask, but if you don't have the seal, all the air is just going to, it's going to come right out around the sides. And in fact, if your filter is really good, more air might come around the sides if you don't have a good fit. So anyway, it's the combination of the filter plus the fit.
And you had a great website for the filters for the quality of the filters. Is there a website for quality? Somebody asked this, for quality of the mask.
So NIOSH keeps a list of which masks are certified by them. Okay. So you can go, I can pull that up in a second. I'll be honest that I don't think it's as user-friendly because it's intended for workers. There is a group right now, full disclosure, I am part of this group. The National Academies of Science, Engineering, and Medicine have convened a committee to think about what are issues surrounding the use of respirators by the general public. So TBD. There will be a report out from that committee at some point. I can't tell you anything more than that, but there may be changes in the future. But at this point, much of the infrastructure in this country for mask and respirator use has really been focused around workers. But I'll pull that page up so we can share it in the chat box.
Great. Jen, do you I have two questions, but I think one is about the box fan, so I'll ask Stephanie when she's done. Well, actually, I could, Jacob, you can probably answer this question. I want to make sure we get to this one. Historical air quality data. A lot of these websites are specifically about current, real-time, and future things getting better or worse, that Stephanie showed. Do these websites, or you know of any websites that provide historical data for specific zip codes or areas?
So that data exists.
Yeah.
I know that you can I've downloaded that data from EPA before. Maybe Stephanie knows of a more user-friendly website that displays it. Probably one exists.
I would probably point people to American Lung Association's State of the Air reports. They put these out. It's either every year or every other year. I don't remember. But they have some pretty good data that shows kind of historical trends over time if you're wanting things at kind of a macro level. If you want things specifically for your area, actually those local air management district pages tend to have good annual reports. This again is a little bit of digging, so it's not super user friendly, but better than trying to get EPA data like Jacob was mentioning, because that can be quite tricky sometimes. So for example, I was looking at information for Fresno recently, and their air district has the reports of every year, sort of how many exceedances they've had in terms of the different pollutants, and has information tracking over time. So if you want more local information for your area, that's probably what I'd recommend looking at. The really granular data, though, like the purple air kind of data and the data that's on the fire.airnow.gov map, doesn't really exist historically, because until these lower cost sensors were available for this really fine scale variability on a map, we don't have that kind of data. So we definitely have data from the governmental monitors going back much longer, but it's a little bit different.
Great, thank you.
All right, so we're going to pivot a little bit to back to buildings. I thought this was an interesting question. I'd love to hear your answers. What role does indoor humidity play as we're talking about the impacts of wildfire smoke? Is there an optimum range for humidity? And if the air is dry inside your house, let's say, because it's closed up against the smoke, should people run a humidifier when you've got your air purifiers running?
Well, I'll say something first about this, and Stephanie can reply. Generally, we haven't recommended using a humidifier in spaces, because there's also concerns of mold and other things, allergens popping up from that. Although this, there's been a lot of discussion about how should we keep our relative humidity indoors, and what effect that might have on airborne infection transmission and exposure to fine particles. Surely if the air is drier, there's potential for probably smaller particles that are, if you're talking about COVID and exhaled breath, those particles can perhaps shrink more in really dry environments. I'm not sure. I'm not aware of any sort of evidence or recommendation for doing anything with your humidity for wildfire smoke exposure indoors, but perhaps Stephanie knows better.
Yeah, no specific guidance for wildfire smoke. I mean, the general guidance for indoor humidity levels is that you want to be between 30 and 50% humidity. 30 on the low end, just because that's sort of what's comfortable. People start to feel uncomfortable and dry below 30. Above 50, you increase your risk for mold substantially. And so that's sort of the standard range. And that would be true for wildfire smoke as well. I think the reason humidity most often comes up when people are talking about wildfire smoke is actually more because of sort of some artifacts of measuring, particularly these lower cost sensors at really high humidity levels. There's some questions about how that may interact with the particles. So for example, air districts that are trying to do monitoring like basically right on the ocean, sometimes have to think a bit about that. So I've certainly had conversations with people about humidity in that context. I'm thinking about wildfire smoke, but no specific guidance about things being different. I'd say the standard, indoor air should be 30 to 50% humidity would apply during wildfire smoke time as well.
Got it. Thanks both. So we actually have a question clarifying something you said earlier, Stephanie. Somebody heard that you said if it's hot, the pollutants in the air might have a bigger effect, but we want to make sure that's what we heard. And is it true that if it's very hot, let's say more than 90 degrees, does air pollution have a bigger effect?
So apologies if that's how that came across. That wasn't how I meant it. So I think there are two separate things here. I think at one point, Jacob mentioned the question of heat and having cooling for your building, that being important during wildfire smoke events. The reason for that piece is because otherwise people tend to open windows because it's too hot, right? So it's a comfort issue, and that then you open the windows and you get more smoke coming inside. So there's that piece. And then I also mentioned, I'm just trying to tease apart all the different threads. And then I also mentioned temperature scale as a comparison. I was just giving that as an example of something else you're probably familiar with that's a continuous scale, right? You have a good sort of innate sense of yourself, what 80 degrees feels like and 90 degrees and 91, and that this is something that goes up little bit by little bit, but that it's kind of a continuous scale. So I was just comparing temperature to AQI as an example of something else continuous. I would not necessarily say that you expect health effects related to smoke to be different at high temperatures, although certainly if you're in a smoky event that is, you've got smoke and it's a heat wave, there are health effects for both those things that you could potentially be worried about, but not necessarily that the smoke is more problematic at high temperature. I hope that helps.
Thanks for that clarification.
Jacob, do you want to say anything about that? I don't know.
Well, yeah, I mean, I think we are getting into a realm where heat waves are really impacting public health. And so then that's another stressor to that, to the cup that I was talking about earlier. And then when you have that wildfire smoke on top of that, you're stressing the body system even more and pushing it into the disease stage. So I do think that is something that we may want to be more concerned about moving forward, especially as the globe is warming. Absolutely.
And it's also a reason that those cleaner air shelters usually are cooling centers too, right? So they have both those things. So if you don't have access to, either or both of those at your home, that's a good reason to seek out those kinds of cleaner air shelters.
All right, and I want to make sure we get to this box question before we wrap up. So the box fans, and somebody has their Fix-It Clinic hat on, which I also wear Fix-It Clinic hat. So I'm curious about this as well. Can you expand on what you meant about the fire safety? And is there any way to fix the older box fans so that they're not a fire hazard, or you think, listen, we're at a space where we just need new fans to protect ourselves in all of these spaces?
So I'll tell you that you're getting a little bit out of my realm of expertise, but I gave a link in the chat box to the person that asked that question. Underwriters Laboratory just recently did an evaluation of safety for box fan filters, because there was this concern about fire risk. Anytime you're using something that's not kind of in the way it was designed for, right? You want to be cautious. And what they found is that using more modern box fans, that the risk is really low. The difference, and this is where I'm saying you're getting a little out of my realm of expertise, and maybe Jacob, if you know more, feel free to jump in. But my understanding of the difference is that starting in 2012, there was some requirement of some kind of fuse that has to be in the box fans, so that if it gets to high temperature, it'll just stop, as opposed to the potential for fire risk. But that is the extent of my knowledge, and I would refer you to the people who know more, and I linked that Underwriters Lab report in the chat.
Yes, there was a question in the Q&A that I tried to answer, and I'll just drop the link to Tex Air Filters, who are sort of doing a lot of the work on these do-it-yourself. There may be more information in there somewhere. I'm not exactly sure, but
it's a good source either way.
Yeah.
Fantastic. Well, I cannot believe it. We have sped through 90 minutes. We're almost at 1:30, and that is the end of our event. So before we close, I just want to say thanks again to Stephanie and Jacob for their presentations. They were fantastic answers to the questions. And that reminds me, thank you to the audience for asking those great questions. If you'd like to stay up to date on research coming out of either Berkeley Lab or UC Berkeley, don't forget you can visit us either at www.lbl.gov or at science@cal.berkeley.edu. Dee's bringing up the reminders for our next events. So we hope to see you in October. We're going to be talking about land management due to climate stressors. And then in November, we're going to be talking about the fabulous world of the microbiome. With that, thanks again for joining us. Have a wonderful afternoon, and we'll see you in October. Bye, everyone.
Thank you.
Thanks.